So this video is about position and velocity versus time graphs, kind of their interrelationship between the two, and how you can use one to find kind of the general shape or of the other one. So first question is, what does position even mean? So again, position is not just where you are. It's key about being relative to some reference point. It needs some kind of origin to set up. You are 2 meters to the left of 0, whatever that is. You need that reference point in order to really set limits as to what you're looking at. So you know whether you're in a positive or negative directions, things like that. So position is not just how far, it's how far and in which direction you are relative to that origin. So when we look at our motion detector graphs, we had a couple different things. And these, remember, the motion detector worked by showing you position relative to the motion detector. How far away from that motion detector are you and which way are you moving? So we have a person walking away slowly, might start close to the detector and not get super far away in a long time. However, if a person was walking quickly, instead they might have a much steeper slope because they cover either the same distance or more distance in much less time. If a person was walking toward the detector, that's where somebody might start away from it and then steadily make their way back towards it, maybe never getting there, but walking towards it. And then finally, if a person is walking toward the detector quickly, well, they might start pretty far away and then get right back up to the detector really fast, as opposed to spending a lot of time not getting there. So hopefully you see that for all of these things, the speed portion, slowly versus quickly, so speed is based around the slope of the graph, the steepness of that slope, the slope steepness, and the direction is based around the sign of the slope. So a positive slope is going away, a negative slope is going back towards. So what else does this mean? Well, it leads us into talking about two different things. We're talking about displacement and distance. So let's talk about distance first. Distance is just simply how far did an object move. So we have an object, it walked, and we want to know how much it actually moved. So to do that, we just have to kind of track how far it went. So the first segment here, we started at 0 meters away from the detector, ended 3 meters away from the detector. So to do that, we walked 3 meters. In the second section, we went from 3 and went back down to 0. So that's going to require us to go yet another 3 meters. So basically like walking out, walking back. So now we've got a total of 6 meters. In the last section, we start at 0 and end at 2. So we have a total of plus 2 meters for that section. So that means my distance traveled for this object would have been 8 meters. Now if we compare that to displacement, it's different. Displacement's more about how much you've moved relative to the origin, and not based on how far you've gone, but how much different your position is than where you initially started. So for an example, what that means is we're going to take 0, 0 as our initial position, and we're going to come out here to, after 10 seconds, we ended up 2 meters away. That means if somebody had taken the picture before and afterwards, it looked like we would have been at 0 and then would have been at 2 after 10 seconds. So to find your displacement, displacement is going to be given by delta x, or xf minus xi, okay, final position minus initial position, change in position. So final position was 2, initial was 0, therefore my displacement is plus 2 meters for the entire motion. Okay. If we wanted to break it up into individual parts, well, here we would have had 3 minus 0, which is plus 3 meters. Here we would have had 0 minus 3, which is negative 3 meters. And over here, we would have had 2 minus 0, which is also positive 2 meters. Adding all those together, they should equal this plus 2 that we ended up with, and they do. So even though this person, object, whatever it was, traveled a total distance of 8 meters, their delta x for the entire motion was only plus 2 meters. Now notice displacement has a sign. It's because it matters what direction it's going. Okay, distance doesn't care what direction you're going, it's just how far do you walk. But displacement does care about the sign, so it's that difference between final and initial position. So just this again, just really quick, displacement and distance for this graph. So distance will be the 3 meters for this first section plus the 2 meters for the next section. So we have a total distance of 5 meters. Our displacement for the entire motion is final minus initial position. And we ended over here at 2 and we started at 3. So that means we're going to do 2 meters minus 3 meters and I get a displacement of -1 meter. So what does that mean? Well, it means that we walked a total distance of 5 meters, but based on looking at where I started and where I finished, I'm only 1 meter closer to the origin than where I started. So it's really important to keep track of those two things. Distance and displacement are not always the same value or even just absolute values of one another if we change direction. So in summary, distance has no direction because it's more about how far the object is moved, not about which way. Displacement has both distance and direction because it's defined by the change in position relative to the origin, or delta x equals xf minus xi, or you could also write it as x2 minus x1 if you want to deal with multiple time points along the line. So in close relationship to that, those two things of distance and displacement are the concepts of velocity and speed. So they're both a measure of kind of the rate of change of position or how quickly you're moving. Difference though is that, as we'll see, velocity cares about direction, speed does not. So rate of change is divided by the change in one variable divided by the rate change in another, or y2 minus y1 over x2 minus x1. Hopefully this equation looks pretty familiar to you and looks exactly like how you find the slope in a graph, because that's what it is. Velocity is all about finding the slope of the position graph, how quickly you're changing position. So based on the equation for rate of change, velocity is the slope of the position versus time graph, like I just said. And we have this equation of xf minus xi over tf minus ti. Or you could do x2 minus x1 over t2 minus t1. Now, a lot of cases our t1 is going to be 0 seconds. We'll just start at the very beginning. Therefore, delta t is just usually end up being the time for the problem. But that may vary based on what type of problem it is. Speed, however, doesn't care about direction though. It's just how fast were you moving on average. So speed is just going to be your distance over time. Nothing's going to cancel out. There's no positive, negative, no sign. Okay, it's just going to be distance over time. So a couple examples of those. Here we have a position versus time graph. We want to make a velocity versus time graph based on that. So we need to find the slope of this velocity versus time graph. So we need to always find delta x over delta t. In this case, that is final position of 2, initial position of 0, over the time of 4 seconds. So that equals 1/2 meter per second for this first section. Graphing that, plotting it out, since it's a positive 1/2, we'll go right here. And since it's for the first 4 seconds, we're going to assume the numbers are the same, should be. Okay. For the first 2 sections, my velocity is going to be 1/2 meter per second. For For the next two sections, we're not moving anywhere. My velocity is going to be 0. So I'm going to put that down here. And then for the last section, we moved from 2 to 1. So that means delta x is now going to be 1 meter minus 2 meters. And divide that all by 2 seconds. And we end up with negative 1/2 meter per second is the velocity for the last 2 seconds. So my graph would look like that. But the vertical lines don't really exist. You can draw them in if you want, or dashed lines, either way. I'm okay with that. But that's how you would take a position graph and turn it into a velocity graph. Now let's take a little bit more complicated example, but not too bad. We just need to break up each individual part. So this part would be 1 minus 3 meters over 4 seconds. We went from 0 to 4. So 1 minus 3 is negative 2. So this first section is negative 1/2 meter per second. So let's draw that in here. Negative 1/2, whoops, for the first 4 seconds. Here now we had a change of +1 over 2 seconds. So that means we have the same value, absolute value for the slope, but opposite sign. So we're going to go up here, there, for those next 2 seconds. Now here we have a decrease in negative 2 meters. It took me 2 seconds to do it. So my slope down in this next 2 seconds is negative 1. And then we go back here again, +1 and 2 seconds to do that. This is taking me back up to +1/2. And I'll put in dotted lines for now, but like I said, if you want to do solid lines, that's totally fine. So hopefully that makes sense in terms of the two concepts, the idea of position and displacement and distance, and speed and velocity, and that relationship between them, and allowing us to figure out how to create one graph from the other. So just quick differences: velocity and displacement are vector quantities. They have directions. All that really means, not just a value, but a direction. The sign indicates the direction, and it's based on the difference between beginning and end of the motion. So speed and distance are based on scalar quantities, meaning they don't have direction, doesn't matter. There's no sign because of that fact. And it's based on the entirety of the motion with no relevance to where the origin is. Doesn't matter where the origin is, just how far did you go. And not relative where you are next to it, or did you move back, forward, away, or towards. It is just purely based on how far you went. So hopefully that made sense, and hopefully it helps you guys figure some of these concepts out.